Screen, video preview. Should jump over to alright, cool. Actually, I suppose we can rotate this part around to show you what it's reading. So the hue of the lights is controlled by, make sure, okay. Cool beans. So the hue of the light here, pink lights, is actually controlled by the temperature gauge. So I've got it mapped to a range of 55, which my wife wanted to change, to 65, to 85. Then it changes the value from more red to blue. So that gives us a nice temperature range. So right now 70, it's kind of purplish, but actually I'm going to change this kind of to green because the 70, say 69 to 70 range is usually pretty good. So, but the problem I'm having is the Arduino board here is actually going to be kind of big for the barrel that I'm going to stick it in. This is just to cut up a Pepsi bottle, or yeah, actually Diet Coke bottle. So I'm going to replace it with an Arduino, a Mini, Mega Mini by Adafruit, to go ahead and get that. So I'm going to solder this in, and then probably attach it all to this Perma Proto board. Actually, the one I'm going to use here to help solder this up. And that way I can actually all fit it inside the bottle, connect the lights up. Actually, this might help my power a little bit too. One of the issues I've been having is because the regulators on the Arduino Uno actually limit the power to, so I've been feeding it 5 volts on the socket. It'll actually reduce it down to about 3 volts, basically chops 2 volts right off the top, which isn't enough to power both the LCD display and the lights. So I've been having to power it through the USB port. And so ideally I'd like to move to just a standard power supply. So I'm going to try using, this is an Adafruit Mini Metro board. And oops. So the Mini Metros are actually, it's a Atmega 328, same as the before, or as normal. It just gives me the advantage of it's really small. It uses a more recent connector to hold the USB ports in place, and should actually give me hopefully a little bit better power settings. So since I can just use a regular power port, and I'll be able to use a phone charger instead of having to use a regular wall wart or fat USB connector is like for the Unos. I tend to be an Adafruit junkie. I like their stuff. Also like SparkFun and Pololu for robotic stuff. So, but this is just a simple light, and this board is probably overkill for the light itself. I'm trying to remember where my cameras are. But it should allow, basically, because I want to put this in here, it's also going to allow me a little bit of room for expansion, because I think eventually Helen's going to want it to change by daytime, and so it could probably hook up a GPS unit. And more I/O pins give me more expandability for future use. So, and I'm vibrating. I think I'm getting an email. Yep. Sorry, my nose itches. The biggest problem, well, not really a big problem right now, but I'm going to make sure that I'm getting everything I need. I like my wet solder holder is an old ashtray of my parents. My dad passed away earlier this year. And so in honor of Dad, I've been using this as my thing. Where did my solder go? There it is. So, always wear safety goggles, kids. I used to not care about safety goggles and stuff, but then I read about one of the problems they have when they're doing MRIs, that it'll suck droplets of solder right out of your eyeballs. So then I decided to wear safety goggles, because hey, can't beat that. So anyway, I just stuck the Perma Proto board there, give it a little bit of solder to tin the end, using a Hakko digital soldering iron. I actually really love it. Come on. There we go. Yeah, joys of soldering. Oh shit. Joys of the camera falling over. Really, you're supposed to wear a mask too, but as long as it's well ventilated, you should be okay. I think my wife left her phone here because I keep hearing things buzz behind me. I know it's not Bob Ross, but you know, hey, it is creative. And it's something I enjoy doing. working computers normally, so it's cool to see the hardware side to do more hardware specific work. And so it's interesting. And okay. I was worried it created a solder bridge there, but nope, looks good. This is also just a test stream to see how well it works. I've set up a, so the electronics cam is actually an old cell phone that I set up the IP Cam Pro software on, and it's a essentially a webcam for Arduino, or not Arduino, Android, that allows the Android phone to act like a webcam or a security cam type deal, and it streams it. So it's actually I had it set up as a weather cam, but then I decided to do this, and this seemed much more interesting than the weather. Not a whole lot more interesting, but at least more interesting. Oh, there we go. So I've got a little side light here set up so that I can check out the board, check out my soldering contacts. Everything looks good. It's actually one of my better soldering jobs. So now I've got all of this hooked up on this larger breadboard. I actually want to move it to a smaller one, because if it'll fit on the smaller one, which it will. I mean, this is not an overly complex setup. It's actually pretty simple, but it does. But since I'm trying to consolidate it all down, I'm eventually going to put it on, you know, a smaller size breadboard here, an actual permanent proto board. I want to be able to prototype it here, make sure everything works still the same, test out power, and as long as all of that looks good, then be able to launch it. So let's disconnect it or leave it going. I think the biggest problem with Arduino setups is that you end up with 18 million USB cords for various revisions of Arduino. One benefit too is that I can actually plug this in, upload the code, make sure it at least builds against it, and then plug it all in. Okay. So very simply, I called it Cloud Light. I remember there was a couple of this is going to be considered. I don't know what it considers it actually. I got it from Adafruit, so I'm going to look real quick on their boards section. Adafruit, Metro, Mini, Home. It is a 3. It is an Atmel 328, so it should be just the same. Or ATmega 328, excuse me, made by Atmel. This considers it another version of the Uno, so this should be fine. Oops. Build and upload. Flashy lights all around. Looks good. All right, great. So now I'm going to disconnect the power and move everything off of the other board and onto this one. Of course, the ambient light in the room just dropped by 100%. Since the Metro is pretty much just an Uno, I can just unplug things directly from here and over into here. So I want well, actually, I'm going to migrate all this crap. So the LCD display is an I2C display. And I keep looking sideways because my chat window's over there. So we should just be able to use the same. Let's see, let's consolidate a bunch of this down. Pin 6 is the data pin for the pixel display, for the LED lights. I2C for this guy. This is a DHT 322. Well, AM2302 or DHT22, I believe is a sensor type. It's kind of a slow sensor. It doesn't read really fast, but in this case I don't care that much. I'm only looking for really whole integer digits, so I don't care if it's a bit slow. The only thing I'm a little worried about is I might have to lengthen the power wires for this guy, simply because they're, let's see if I can get it, oh no, that'll be fine. The way I would like to mount it is to have the LCD display on the front side, and then the data and clock. Let's see, clock is 4, data is 5. Let me check that because I do not remember. I always vastly prefer it when it's actually labeled on the board, but none of the Arduino is actually labeled. Which pisses me off no end. Where is data and clock? Yeah, this is the joy of work. It's like, oh, okay, I'll find this. I'm like, oh, now I got to look it all up because I don't remember. I know it's pins 4 and 5, analog 4 and analog 5, but I don't remember which one's which. One is the clock, one is the data. And the wire libraries should always be the same for them. So as long as you know what it is, looks like, clock is 5, data is 4. Which means I got these backwards. I actually don't know what the effect would have been if I'd run it with them backwards. The joke is you let the magic smoke out, which is all electronics run on smoke, and when you let the smoke out, it kills it. So my response to that is ha ha ha. So funny. So the DHT sensor itself has, of course, 3 wires. The only real thing that it adds extra is there's a pull-up resistor, a 10K pull-up resistor on between the positive line and the data line. Let's see, and that was for pin 2. So I'm just going to run its power over into the power rails. Well, actually, no. Oh, let me not do that because I am running a 10K resistor between its power and its pull-up line, which should be okay, but still, let me not chance it. Okay. So its data line is going into pin data 2, or digital 2. So it is a digital sensor, which is actually kind of cool. So it's not actually sending in analog data. Let's connect this across. All right. Okay, we're good. I'm getting a nice view of the top of my head as I sit here and plug this back up. Okay. Now, the wiring for so that's the LCD display and the sensor itself. Now the strips, which are Adafruit NeoPixel, it's actually a 1 meter, I think it's a 1 meter strip. Since I'm doing full power on it, I do a capacitor across the positive and negative leads. And the reason for that is so that it kind of evens out the power draw, from what I understand, because they've changed their documentation about it. This kind of goes into their best practices. And then you also put a resistor on the data line itself. Oops. There. And there. And the resistor on the input line prevents, I'm guessing, just prevents too much current from going straight into it. So I'm going to do it, just bridge the resistor right on the breadboard itself, because this is how I'd probably, if we're going to solder it up, this is how I'd solder it up. Straightening out the wires. And I had this on plug pin 6. Okay. Now I just need to give power on the NeoPixel strip. And they're WS22. Oops. I'm want to say. I don't remember the exact chip name that's in them. Adafruit's brand name is the NeoPixel. WS20120. So we can get that in close. And autofocus fail. Anyway. Yeah, WS20120 is the actual chip itself, and there's a small resistor right on the front side. But what's nice is you can actually just, it only takes 3 pins, and they're, of course, ground, 5 volts, and digital, and it's sequenced, so it goes, you know, your input here goes all the way out, and you can chain them together on the outside. And because it's actually digital, you can control each one individually. So I can control the brightness and the hue, saturation, and each one is an RGB, you know, LED set of LEDs in there. And so with that, I can actually control how much and how bright the actual colors are. So now let's actually give it some power and see how we do. Because now we're using, what am I missing? Oh, I didn't connect the actual power from the 5 volt right to the 5 volt rails themselves. As always, it greatly helps to actually plug in the grounds. Because I've got a capacitor on here, I'm definitely plugging in ground first. And I don't see another little red. Huh. I could probably simplify this a lot more by chaining some more of these together, but I'll do that as I do more prototyping. Okay, much better. Light there. Lights there. They start off blue. And go to fuchsia as the actual temperature plugs in. And I've got a temperature. .5. All right, great. So while I'm still in the prototyping stage, let's see what I can do. So I could probably combine the NeoPixel power all together with the actual sensor power, but I think I'm going to leave them separate. I'm okay with having it kind of spread out, because actually when I put it on the breadboard, I'll cut custom sized wires so they won't be just everywhere. What I am going to do is go ahead and shut off. Oops. Shut off the soldering iron. So it's the only problem with using a cell phone tripod is that it's slightly imbalanced. And it stopped streaming. But because it's imbalanced, it tends to fall over a lot. There we go. That should be better. Much better. Trying to spare you the view of my crotch. Okay, so we're happy with that. This has the added benefit of it's a much smaller board, so we should be able to, you know, move from this giant thing down to that small thing. So perfect. I also have a power supply that actually has a push button for this kind of thing to give me an on-off switch, which is one of a feature I like for anything that's a lighted thing that's going to be moved around. I like to be able to turn it on, turn it off, independent of just pulling it out of the wall. That gives it a little bit more flexibility as well. Just in terms of how I choose to install it. So. All right, so one of the things I wanted to add, and this was a request. The lights don't flash, so I'd like to make it so that the lights will actually kind of pulse or flash as they are doing their thing, so that kind of give it, so as it gets cold, a stormy effect, or have it randomly go to a stormy mode. So let's jump over to the code. You get code cam now. Oh, I see. Oh, I should have done that. In my screen layout, I should have actually made it a little bit bigger, but then, and it's hard to tell. Okay, yeah, you guys can see that fine. So I was wanting to make sure that it was actually scaling correctly and visible on the screen. Because it's hard to tell what, because I'm keeping it shrunk as long that it's clear as far as the text. So a quick rundown of what I've got already. Actually, since we're doing this, I'll go ahead and migrate the camera really quick. Okay, good. So the DHT includes, or for the DHT sensor itself, of course, the wire library for the I2C, the liquid crystal. This is actually a custom liquid crystal library provided by Adafruit, because I'm using on the back of the actual temperature or display itself. This will be hard to see. It is a I2C backpack that takes the LCD output, and maps it to an I2C device, so I can actually use 2 wire instead of all 16 pins. It makes it a little bit easier to control. Makes it a lot easier to control with only 2 pins, and that's what I2C is great for. So it's very nice to be able to have that available. So some different definitions for the sensor and define the sensor itself. So I actually don't like to use the delay very much, the delay function, because what it promotes then is as you get longer and longer in your code, or your code base gets longer and longer, you've got to wait for the delays, and so you've got to calculate things. Well, if this is going to happen, then this is going to happen. You know, so your delay function assumes that it's only going to have 500 milliseconds or something, and you'll be in your next iteration. If you move away from that and just use deltas, say after 500 milliseconds have elapsed, do this, it makes your code a little bit more reactive to the change in time instead of expecting a certain time to have passed. It's a slight change in programming, but for Arduino stuff, I think it makes it a little bit better, because you end up with code that doesn't have delays built into it, and then calculations of the delays. So just use deltas. And so I know I'm going to wait 5 seconds between my readings of the temperature gauge. And 5 seconds is more than enough. I actually could probably go for a minute for this thing. Um, as we've been sitting here, it's kind of jumped around a little bit, but not too much. So that's one of the things that I've been, why I like using a delay here. By default, it gives several values, but humidity, temperature in Celsius, and temperature in Fahrenheit are all available. Oh, hold on. I'm getting paged. Just a moment. All right. Be back in a second. Okay. Crisis averted. We're back. Interesting. Okay. Yeah. Coffee time. I should actually probably comment this. I have a little thing to check the last temperature because it also, I use that in a later bit of code, and this byte is for the code that actually does the color changing. So there's my liquid crystal display. It's I squared C, so it's on address 0. This is the degree symbol. I use the char a little bit later, create char function, and you can actually define the glyph that appears by flagging the different bytes on. So this is actually a byte structure for what a degree symbol looks like within the LCD strip. And of course, there's my Adafruit NeoPixel initialization string. I tend to call millis a lot, so I try and write it to, if I know I'm going to recall it several times, write it to a variable and then use that variable over and over again. So debugging is true, so I wrap my serial print lines in debugging, so it doesn't do it if it's not needed. When I start finalizing my code, I'll change that to false, unless I need to test something. So DHT is the DHT sensor, strip is the NeoPixel strip, LCD, of course, is the LCD backlighting. And this create char is actually assigns to, there's 8 registers where it can store characters, and so it stores in the first register the degree symbol, that bitmap that I had above. So call our millis function. So millis actually can wrap around. It's an unsigned long int, and after about 50 days of uptime, it'll wrap. So this is actually just a little thing to detect that. Not that I expect it to go for 50 days, and that's why both last time for the DHT sensor and last LCD time are unsigned longs. I don't know if you saw that from the initialization code. So that's why that's there. And so this is where I use, instead of a delay function, I say, if my current time, this DFT millis, is larger than the last time I read my sensor, or is larger than the delta, so basically is now minus the last time I read greater than the delta that I've got, then go ahead and read the sensor. So it calls the DHT read DHT22 function, which is defined down here, where I set, okay, for my sensor, pull the humidity, pull the temperature, Fahrenheit true. If it fails to read, return it. I should probably make it set that to something, incorrect, or set all the temperatures to -99. I'll work on that later. It also calculates the heat index, but I really don't need that. And of course, the debugging code to actually print it out to the serial port in case I need it. So that's where that handles reading the sensor. Called DFT to get my millis again, or assign millis to DFT, is the last update time greater than the LCD delta. Basically, do I need to update my LCD faster or now? If the last temperature is not equal to the last Fahrenheit reading, and the reason I do this is if the temperature hasn't really changed, there's no reason to actually change the temperature. So that's where that comes in, and basically it only does an update on the LCD, because all this is LCD settings. If that temperature is actually, if it's actually a degree difference. This part actually handles the mapping. So from 65 to 85, On the color wheel, it goes from 171 to 84. Now the way it's supposed to go is green to red to blue, RGB, yeah, red to green to blue, then back to red. So what I tried to optimize was the fact that the blues would be mostly the cooler colors, and the higher colors would be 80 in the 80s. Unfortunately, what happens is that leaves out the greens. And really what I should go is blue to green, then green to blue. So I think I'm going to actually add, so the map isn't exactly where I'd like it to be. So what I might do is neo above optimal and neo below optimal. Actually, that sounds better. And this just iterates through this section of code, just iterates through the pixels, sets them to whatever the neo color that I've detected, basically through that map function on the color wheel, and assigns it. So let's show you the wheel code itself. It takes a byte of wheel position, and so it goes from 0 to 255 with the transition from red to green to blue, and then back to red. So if the wheel position is less than 85, it's mostly green at 0, and then goes to red at 84, just based on the R, which is wheel position times 3. So if it's at 84, that's going to be maximized. The green, which is 255 minus wheel position times 3, so that'll minimize green at 84, but maximize it at 0. So that's where the mid-range is that. And so the same for if it's less than 85. If it's less than 170, reduce it by 85, so get me that halfway point, and then somewhere within that it's going to be on mostly red or blue in this case, and no green at all. And then from blue, from 170 to 255 is going to go from blue to green, just by modifying these colors. So what we really want is to go ahead and change this around, because what I would like it to do is be green mostly in the middle when it's in the mid-range. So since this is green to red, then red to blue, and then blue to green, let's rotate this around so that our midsection here is going from blue to green. So at 0, we want it mostly red. Yeah, okay. So the way this does is green to red to blue, and then back to green. But we really want it to go blue to green to red. So let's take, in this case, since I'm going to go ahead and redo it anyway, and this is let me call this wheel 2. That way I preserve my original function, so if I screw it up, I can go right back to it. Hey Milano, sorry I didn't see your message. What I've got over here is a temperature controlled DHT sensor that of course displays the temperature that it's reading, and then based on the temperature it controls the lights. So if I hold the thing in my hand to force it to start increasing the temperature, you'll see that it starts changing both the color of the lights and the temperature reading. Give it a second. Give it a long 5 seconds actually, because it's 5 seconds per reading. Oh yeah, so you see the lights in the background are slowly, move my hand out of the way. You can see them slowly changing in color as the temperature goes up. And so there is a slight delay because of the fact that it's counting on the temperature change and the time delta to actually make the change. In this case, the time delta for updating the LCD is actually pretty short. It's only like 100 milliseconds. So I'm looking for a 100 millisecond display before updating the delta, but only 5 second, but 5 seconds between reading the sensor. So really I could go for 2.5 seconds here, but that should be fine. Let's get this nice and hot before doing this. And this way it'll actually start decaying. We can use the decay. Wow. So this is turning this bright, brilliant red, the lights themselves, as this is going up. And the cameras don't do it justice for yeah, so 82.4. Yeah, this is a cool project to work on. And the eventual idea is that I'm going to make it so that it's a there are pictures on Reddit recently about the cloud lights, and that's what I want, but I want it to react to temperature versus just being a light and looking kind of cool. But then I also want to make it do a little bit extra, a couple of extra things where it's like flashes some more and stuff like that. So that's what I'm actually working on in this case. Oops. Really, I should get a cup of coffee and put it over here because it'll make it heat up super quick. But my coffee is actually kind of cold. It's not very warm right now. It is fun to work on. It is the kind of thing that I enjoy. So anyway, we want green under mid-range. So blue to green. Let's take this part out. We'll put it here. No, actually, we'll put the blue to green here, and then the blue to green here, then the green to red in the middle, and then the red to blue at the top, and that way it cycles around to blue. And we can still leave the wheel position where it is because it really doesn't hurt anything. So blue to green. It's going to be here. Green to red. It's going to be here. And then this one is red to blue. Mostly blue at 0. Let's check our math. 0. Actually, it's going to be mostly. Actually, these two should be swapped. Because we want it mostly blue at 0, so we've got to maximize this value. So that should be wheel position times 3. And then green as it approaches 84. So at 0, this will be 0. 0 times 3. Oh, actually, that's right. So it'll be mostly blue at 0. At 84, mostly blue, mostly green, mostly green, mostly red. Yeah. Mostly red at 85 and mostly blue. So check our math. At 255, it'll subtract 170, which will put it at like 84. So 84 times 3 is 252, so minimizes the red, and 84 times 3, 252, maximizes the blue. All right, so that should be good. So what we can do is just change our function call here. We can still keep our mapping because we want the minimum Oh, actually, this doesn't. So we want it to be 0. Oops. Where's my code folding? Blue to green, red at 169. So let's do 170 as our max and 0 as our blue. So 0 to 170. So the map function is actually nice because it assumes a linear mapping. So it actually should still work pretty well and allow us to actually make the code function correctly. Let's push it to the Arduino. Like I say, it's in a way the board itself. It's a Metro using ATmega 328, kind of like an Arduino Mini, but I like Adafruit stuff. They actually made a really good board here, and so it should give me. Oh, that's nice. So we've gone to green because green is actually in our mid-range where we're at 170. So we should be able to test it and make it go from 170 to. Let's go ahead and do. We got debugging turned on. So N is our color value. So it starts off by default, everything's zeros. So it goes to a high color, then it jumps to low. So we're getting 78 degrees, 77. So this is cooling down from where it was. I would actually like it more red as it's approaching that value. So that's interesting. We might have given it too wide a range. So this is potentially a problem because what's happening is the range of between blue to green to red is actually pretty narrow, but it allows for, so we're at 102, we're closer to the green range of the scale. Also, temperature hasn't changed that much. It's cooling down very, very slowly. How slowly? Super slowly. At almost like a non-linear ramp up, but that's, the map function is strictly linear. So grab the temperature sensor. Let's see if we can make it jet hotter. What's funny is the humidity shoots up as well. It means I've got sweaty palms. And I promise I'm not a shill for Adafruit. I just use their stuff a lot, and I really like it. I also really like their tutorial section, and they've obviously put a lot of work into it, and I think it provides great information. So, okay, that's better. So, let's go in green here. I'd actually like it to go. I'm watching how it turns color. So I've set 85 as my maximum when it goes all red. And so it should be hitting, so it's at 144, so 153, and that was a degree jump, so at 185, or at 85 degrees, it should hit 170, which makes sense. It should hit it in a second here. It should be totally red by then. Okay, great. Yeah, it's getting super luminous here. As it goes from the past the red at 85 degrees where it's all red, it's actually getting into the, you can see my Adafruit orders coming in. It's getting into the lavenders as it goes red to blue. Yeah, there we go. Which is really pretty on its own. Alright, DHT sensor. There's got to be a way to cool it down faster. I thought about sticking like ice cubes in a jar or something, but then that gets water all over my desk as the condensation around it happens. What we could probably do is hook up a fan or something too, but it gets kind of cold. And this actually should allow it to go faster as far as actually displaying the cool down effect. Okay, so this looks pretty good. Update the comment to actually reflect the code. Alright, so now that looks good. Now what I wanted to do, so this is the strand test code for testing a NeoPixel strand. They run it real quick, usually just to test out the make sure everything works right. But what I wanted was, at one point I'd made some goggles using goggles and ATtiny, and this was a demo from Adafruit. But one of the things that the goggles did that I really liked is they have like a little flash where it goes just super bright white for half a second and then off. And so what I'd like to do is have that same effect, and so I wanted to look through the code here to see if there was a thing. And I think this is just for let's see, where did I see it? This is one of the cool things about working in electronics is, especially for open source stuff, if you see something you like, you can say, oh, how would I do that? How would I make something that's similar to that? I don't see it here. I know it's not there, so let's see if we can add something that'll make it flash. So I've got a meter strip, so I've got about 60 pixels themselves. And I'm constantly on their site because this is one of the things they don't tell you about programming, is that as you do a lot of it, you start remembering various things, but not necessarily all of them. Let's see, especially for things like random functions where you're trying to, everybody has a random number generator, but it's different between the way you would call it in Python or the way you'd call it in C. And so in this case, I'm looking for a random function up to the strip of known pixels. And how many should we have flash? So this is 30 per meter. I think I've got a 2 meter strip here, so this is 60 pixels. So let's do 6 of them, and we'll have them do just a real quick flash before returning to the original color. And that's the beauty of keeping the neo color actually in a variable, because we can make them fire off real quick when we want it to happen. Want it to happen when? Nah. There. It gives us a pretty small chance to actually cause this to happen. short because I really don't need any. I want to iterate over all pictures, so just do it 6 times. Set pixel color, we'll do random up to num pixels. So that gives me a random pixel. We'll set the color to white. White is all on, so this would be color is a byte. Should just be 255. What I'm deciding is if I want them to all 6 of my random pixels to just flash at once, or just do flash, flash, flash. We'll do flash, flash, flash. But then set it back to the color it originally was. So white back to the original color with a random chance of it happening. This might not look like I expect. In fact, I can almost guarantee it doesn't look like I expect. Move the lights closer so that they're actually in camera. And that was everything. I like how opening the serial monitor actually causes everything to reset. And what I didn't do All right, initialization complete, and should go green. Green. Serial monitor. Let's see what we got. What I forgot to call strip.show. resets it, but it doesn't actually push the changes in. All right, let's see if this triggers. Interesting. Gives it a cooler effect, but the color is not uniform. It's not just flashing like I want. And I'm guessing what I'm needing to do is hit it twice and then cause it to actually trigger. And I think 100 milliseconds is not long enough because the limit of human perception is, I hate making this longer. Especially since it seems like it's coming back to a color that it should not be. Yeah, it's only making them blue. It's not actually letting them. And this is the debugging process. Yay! Let's see what we can do here. I wonder if they've got a define for white. No, they just call color white with specific. Well, actually, I could just call strip.color. So I believe that returns a color because color wipe function requires. Yeah, UN32. So strip.color should give me what I want. So this should be. And this should be incredibly short. It should just go bang. It's the joy of hardware debugging. You're constantly looking from the code to the actual implementation. back and forth. The problem now is they're triggering white, but they're not reverting. It's the random. I was assigning the pixels, but not actually putting them in the right place. I was using I, and I should have been using that same random number, so I needed to use the same value for the one I put and the one I put back. Semicolon, semicolon. This should allow the random to be triggered. Much better. Yeah, I like that a lot. Less Christmas lighty, more thunder / lightning was the idea I was going with, so that's good. Very nice, very, very nice. So what's funny is it tends to flash. So I'm noticing that the flashes are kind of red, which means it's not necessarily white. Well, obviously it's not white. What it's actually seems to be doing is some kind of wonder if it looks red because it's already kind of green, and so when it flashes white, but you see the red because of your eyes expecting the green. What is the actual temperature? So 72 degrees, which is about right. It's actually pretty cold. Well, not cold, it's actually great. You can make it colder by opening a window, actually, which I might do. So I'm not using my trick of calculating a delay here because it is going to be so fast, and I do want it fairly fast. I don't think I need to trigger the flashes any, although, so in 5 seconds it's triggering about once a second. What would actually be neat is I could tie it to. Too bad it doesn't have barometric pressure, because then I could detect when the pressure was low, so like when it's definitely stormy, have it actually trigger the lights. So let's so this is a 10 in 500 chance, so it's 1 in 50. Oops. So the range for random is 0 to 1 minus your max. So in this case it goes 0 to 49. So this is the same number essentially. It's a 1 in 50 chance that it'll actually trigger. So I am triggering about once every second. So let's do 1 in 50, but let's also add a delay so that it will not trigger unless it has been some time. So let's do a couple of things. One, we'll go ahead and move this initialization because we don't need to initialize it each time. We'll pull it out of the loop and actually put it up here in our code. This looks good. Flashing specific things. So int which picks sets 0. Let's do yeah. Long, unsigned long. Well, we're to spell signed wrong. So if it's that, and so 1 in 50 chance that it can happen, and it will only happen at least with 4 seconds between each flash, each set of flashes. So and that way it's like a ripple effect where it should do it and then wait. So yeah, there we go. Oh, perfect. That way with it constantly flashing, it'll get annoying after a while. If it's unexpected and you're kind of waiting for it, it'll be a little bit different. So this way it sets a minimum threshold on what we want it to do, and the actual things show up. So, okay. All right, looks good. So next will be some soldering and some layout, but I'll probably do that a little bit later, and not now. I'm actually happy with where I've gotten it to, and I'm going to go ahead and take a break for a little bit. So thanks for watching, and I hope you enjoyed it. Let me jump over to the Arduino titles.